Thank you, everyone. It is a pleasure for me to be back at the University of Sydney. As you heard, I was a lecturer in psychology here quite some time ago. In fact, my office was about 30 metres that way, maybe 40 metres, I'm not quite sure, but across the road. And I remember seeing this building being built in its early days. That's how far it goes back. I was also briefly with the Institute for Teaching and Learning doing central support for the university back in the very early days of e-learning technology. And then the rest of my life was spent mostly at Macquarie University in the Centre for Research on e-learning technology. So that's kind of my broad background. And much of that work was based around this piece of software, LAMS, or the Learning Activity Management System, which is a learning design system. And I'll say a little bit about what that means for me as I go along in the presentation. I was just sharing with Lena a moment ago, we started LAMS in 2002, so we're up to 15 years now that we've been doing this project, and it's been used sort of all around the world in different ways. I think it's translated into over 30 languages. I think there's 80 odd countries that have done at least something with LAMS. And I found out from a friend, I didn't even know this, but one of the places that take quite a bit of usage of LAMS over the years has been in Greece. And he just got back from a conference over there, and they said there are 100,000 users of LAMS in Greece. And I didn't know there were 1,000, so that was a really exciting and lovely thing to find out. Had a lot of use of LAMS also recently in Singapore, and that'll be the focus of my talk today, is a particular project at the Lee Kong Chan Medical School, which is at Nanyang Technological University in Singapore. So that'll be kind of the heart of what I'll talk about today. But it's been interesting for me to watch in Singapore, a country that's looked very much to innovative methods of technology to enhance what it's doing, has really latched onto LAMS in a range of areas as a way of implementing that. So if you're new to LAMS, or if you haven't seen that much of it, I hope I'll give you just a little bit of a taste today of what it's about. You may want to look into it more in the future. So just a little bit of an overview where I'm going. And I should say I prefer this in a pretty relaxed style. I would much rather you ask me any questions along the way than hold them till the end. Happy to have questions at the end as well. But please just, whether it's a clarification or a question, that's no problem at all. So I just want to say a little bit about what I think learning design is. I'll say a little bit about team-based learning as a particular pedagogical approach or sort of teaching strategy. Then I'll talk about the use of team-based learning and LAMS at the LKC School of Medicine. So I'll give you a bit of an overview of their project, show you a bit of what's done, show you some demonstrations. After I've done that, I then want to sort of step back a bit and talk about, from the perspective of the LAMS development team, some of what TBL required LAMS to do were things we could already do, but some of them were things LAMS couldn't do. And I want to talk a little bit about how we came to think through the changes needed to LAMS to be able to do team-based learning. At the end, I'll just say something very briefly about some similar work done at the University of Western Sydney here in Sydney in their medical school, doing a sort of a cut-down version of team-based learning. And I'll wrap up. So that's just a bit of where I'm headed for today. So, what is learning design? Well, the phrase itself's been pretty debated within the literature, if you've come across it at all. And about 4 or 5 years ago, a group of experts in the field, including myself, and Peter Goodyear was also a part of that at times, came together and tried to think, okay, so what is the field trying to say? What is it about? What's in scope? What is out of scope? How do we think of it? Some people at the time had thought learning design was a technical thing, like a technical specification for how a piece of software should run, if you've ever come across the IMS learning design specification. So some people thought that's what learning design is. Others thought learning design was something like learner-centred learning, and one must design learner-centred experiences when one is designing for learning. And in fact, that phrase, designing for learning, was quite common in the UK in some of the work around this. Others thought it was about building a piece of software to do those things. That's where LAMS fits in. Others thought of it in just much more general terms, almost to mean something like instructional design or effective instructional design or non-American instructional design, if you prefer it. There's been a bit of a history of debate between European versions of learning design and other ideas that have more American instructional design focus. So with that bit of background, we all got together and tried to say, all right, what can we agree on that we think learning design is about? And that led to a paper that we wrote called the Larnaca Declaration on Learning Design. We gave it the fancy name because we had a really nice lunch in Larnaca at the end of this. We were meeting in Larnaca in Cyprus, and so that seemed as good an idea. Had the added benefit that there was LD on LD, which appealed to us, And then that led to a book that we published with Routledge. I edited it, but it's got the first chapter is that declaration and then a whole bunch of other chapters. For those of you who are interested, I've got copies of this book. I can do them for $20 if you're really interested as something afterwards. But probably the most important thing is that the first chapter is actually freely available online because JIME decided they would publish a special edition to go with the book. So if you're interested, that URL's got it. I'll make sure that Ling has the slides from today so they can be circulated around. You can Google it, it's not that hard. But that chapter that's the core of the book. It's really our whole theory on what learning design is. And within that chapter, we talk about a number of learning design systems like LAMS and others, and we compare and contrast them. And for those of you sort of familiar with some of the terms here, sometimes people talk about an LD authoring system. That is a system that can create learning designs, but it doesn't do anything about how you would run them with students. Other times people have talked about a runtime system, that is one that will actually run the activities with students, perhaps taking the output of some other learning design authoring system and then running it. And a few have also talked about monitoring systems, how the teacher can track the progress of students through the system. Within the LD literature, these have often been quite fragmented and often different systems, and they don't always fit together very well. From the very beginning of my work on LAMS, I always had the sense that if the whole system wasn't glued together at once, it would be very difficult for teachers to use practically. And so from the very beginning, we built LAMS to be all of those things as one integrated package. That had certain hidden downsides to it, but it did have the upside of making it sort of an easy to use or relatively easy to use packaged system. If you've not seen LAMS before or you're not quite sure what a learning design is, let me just give you one very simple example. So there's a teaching strategy or a pedagogical approach often used in the sciences called predict, observe, explain. Many of you will probably be familiar with this. In very simple terms, you give people some kind of a scenario like an experiment that you're about to do, but before they see what happens, you ask the students to predict what they think is going to occur, and there's often a bit more to that. You then do the experiment, or you show them a video of the experiment, they observe what happens, and then afterwards they try and explain what they saw. So that's the bare bones of the pedagogy. When it's implemented, it's often got a few little extra bits, and so this is a sequence of activities in the LAMS authoring environment that's been built to implement this approach. And so the very first step, let me see if I've got a laser pointer here. So that's just a kind of introductory page, these activities we're going to do today. This is a description of the topic, and this particular one was when the astronauts went up to the moon, they had a hammer and a feather, and they were going to drop them at the same time on the moon and see what happens. I've often thought it's possibly the most expensive instructional video ever made. So, there we go. So, there we go. So that's shown there, and it describes the scenario, but doesn't show what actually happens. The next step is 3 steps that are part of the prediction stage. The first one is students are given a number of possibilities of what will happen to vote on as their prediction. And so they can choose these. The system in LAMS's case will actually collate all their votes and show them back to the class so they can see the spread of ideas. The next one is then a commitment stage. Sort of how confident are you that your answer was right before you happen? So you're extremely confident, moderately confident, not at all confident. And so the kind of metacognitive skill of reflecting on your own understanding is a key part of what makes this so effective. And then the third part was a reason. So why do you think this is going to happen? So students would type in a couple of sentences, and in LAMS that would collate all the individual sentences people have put and then stick them on one page anonymously so the students can all see what each other's ideas are. So that's all the prediction part of the sequence. Then there's the observation part where it shows the video of the hammer and the feather being dropped, and they look at that, reflect on what they think they've seen. Typically, you'll have some kind of, students will need to describe just in plain language what they saw. They don't try to interpret it relative to their own previous theory. They don't argue with their colleagues. They just try and, in good kind of scientific practice, describe what they saw in the observation stage. So that'll typically be part of that step. And then finally, some kind of explain stage, where in this case students have got a discussion forum. They will then try and explain what they saw, what their prediction was, why they lined up or why they didn't line up, try and come up with theories about what could be explaining what's going on and debate with each other. So that's just, it's pretty simple, but that's just a sequence of activity tools taken from this palette of all different tools. They're kind of typical LMS type tools. If you're not familiar with LAMS, chat and forum and quiz and that sort of thing. There's a couple of other more interesting ones, but that's a good starting point. And then in LAMS, I just drag and drop them into this main area. I draw lines to connect them up, and then I would go inside each tool to describe the details of that tool. What are the choices for the voting, or where's the video that they're going to look at. So I'm not going to try and do a lot of detail on LAMS. It's something you can look at after today if you're interested. But I just want to give you a sense of, that's an example that brings together two things. One is a teaching strategy or a pedagogical approach, whatever works for you, predict, observe, explain. It's got some kind of underlying theory about why that's a good approach and so on. But equally, what you're looking at now is a piece of software that has implemented that in a particular way. And so this we can think of as a learning design or a sequence of activities as a kind of exemplar. So it's taken the theory of predict, observe, explain, turned it into a particular example that you could run with students. Now, there's lots of things you could do differently. You don't have to have a discussion forum at the end. You could do this as an in-class activity, and you could do an open discussion in class rather than on the computer. So there's lots of variations there, but I hope you get just the essence of what it's trying to do. Now, here's the essential thing for me about learning design as a field. That thing there is a shareable object. So having built that, I should be able to then give that to any of you as a resource that you could look at, you could modify, you could run with your students. You could even modify it and share it back with me and say, hey, I took your thing and I made these changes and now I give it back.
And sorry, can I just clarify, is that what the students see as well?
Right. No, student view, I'll show you a student view in a few moments for the TBL example, but this is a kind of visualization just to help the teacher or the lecturer see what's going on. So for me, the shareable bit was essential to the whole field of learning design. That was what took it beyond what we've done before. If you've worked with a learning management system, or Blackboard or Moodle or whatever, you can build your course, you can do all sorts of nice things. You might not have quite the sequencing capabilities of this, but something not too far from it. But if you wanted to take a good bit of pedagogy out of your Moodle course and then give it to a colleague, that's not easy to do, if not impossible. Whereas learning design as a field and LAMS and other systems, at least hopefully, had that idea at their very heart. That was what they're about. They're about sharing good exemplars of pedagogy. And let me go one step further and a little bit grander. In the same way that open source software was all about building pieces of software we could share with each other as programmers and add to and improve and build better software, this is an attempt to do the same thing to education. Could we take, dare I say, the source code of education, good sets of activities, turn them into shareable objects, and then share them with each other as educators so we could work out how to improve them and so on. I've called that, at one point, open source teaching, just when I was trying to be more provocative. All right, so that's just a little bit of an example of what a learning design might look like. And it's worth saying, this is a confusion that occurs in the field from time to time. Learning design is the name of the whole field, but it's also a term that's used for a specific example. So that people will say that is a learning design, small l, small d. So just be aware of that one.
How do they share that?
So that comes out as a zip file, which is basically a pile of XML saying, here are which tools are to be used and in what order and any settings on the tools. And then any resources that have been embedded in them will be packaged within the file, a bit like an IMS content package, if that means something, and then sort of all bundled up and you can hand it around. There's a website called the LAMS community website, which I'm not going to talk about today, but that has several thousand of these shared sequences on it if you wanted to kind of go and have a bit of a look and try stuff out. All right. So this slide I want to just try and capture the key conceptual work that we tried to do in the first chapter from this book on learning design. We had this problem in that part of what learning design had been about was this attempt to create a framework, a descriptive framework for sequences of learning activities. And one of the phrases that had been used in the very early days from Rob Coper's work at OUNL and from then on was that framework aspect of learning design should be pedagogically neutral. Now, that's a great phrase because it normally provokes, half the room when it gets said. But the idea behind it was, there are no neutral pedagogies. Let me be clear on that. There's always some elements of bias. But what that aspect of learning design was trying to say was, could we build a framework or a language that was sufficiently rich and expressive that it could describe many different pedagogies under one framework? And so in that sense, it would aspire to be pedagogically neutral in that it wasn't meant to be biased to just constructivist learning or just instructivist learning or whatever you might be. It might give you a flexible toolkit that you could then choose to run in many different ways. That's the key meaning of the idea of being pedagogically neutral. So that's the framework part, and that's always been essential to the early days of the field. And you can see LAMS as a piece of software is trying to say, here's a whole suite of tools, here's ways of putting them together, and they don't all have to be linear sequences, they could be branched and clustered activities. I just haven't shown you those. So depending on what you're trying to achieve, won't be able to do everything, but should be able to do quite a lot of different sorts of things. So that's the learning design framework bit, and that operates at both the kind of conceptual level, but also the technical level. Like, what would a technical language look like that could describe this, be it in, a specification like IMS-LD, or a piece of software like LAMS and others that would, implement something like that. So that was one part, but there were two problems with that being learning design, because when people talked about learning design, particularly in the UK and European context, they also often meant the wider set of issues around learning design, not just the kind of particular set of activities. And so they want to say that when you are designing for learning, you've got to take into account lots of things like your institutional constraints, the pedagogical interests of your teachers, what type of students you've got, what type of course are you building? Are you building a half-hour lesson or an entire degree? Just a sort of an endless list of issues. So I'll come back to that in a moment with the diagram, but that we wound up saying, okay, we're going to call that the learning design conceptual map, the bigger map of concepts that are behind or around learning design, and we're going to need to acknowledge those, otherwise just talking about the framework is going to be too thin. It's going to be just kind of a bit narrow and thinly focused. The other problem we had was that the reason we all wanted to do this work on learning design was to talk about good pedagogical approaches or effective pedagogical approaches. This wasn't an interest in just, wouldn't it be neat to build a system that could do lots of different things? It was meant to be about improving teaching and learning. So where did that piece come back into the picture? And so we decided that we also need to talk about what we end up calling learning design practice. That is the kind of practices that actually foster deep or effective approaches to learning. And so in that, we found a way of kind of then being able to partition out and saying, all right, so when we talk about something like predict, observe, explain, we can talk about the wider background of why you might do that as part of learning science. That might be the conceptual map. A particular sequence of activities that might do it. That'd be the framework. And then a theory in pedagogical terms about why that's going to help the students to learn if it's built in a certain way. That would be learning design practice. So that was our attempt to say, okay, learning design is this big amorphous term, but we're going to try and partition out at least some concepts within it to help us work out which pieces of the puzzle we're trying to solve. Right. I don't want to try and go through every bit of this. It's in the chapter if you're interested to read it, but this is the learning design conceptual map. So there's an attempt to just visualise all of the bits and pieces that go into thinking about a learning design. It helps if you sort of start down in the middle here. This is where learning design, sort of the central bit is the representation, the framework bit, as well as the ideas of sharing it. And we also talk about guidance. That is, what advice would you give to someone if you were giving them a learning design? Here's how to use it. Here's how you might want to change it, those kind of concepts. So they're right at the heart of it. There's all the implementation issues of how you run it in software, how you track what students have done in terms of their evaluations, their assessment, learning analytics, whatever you've got. But then up here we acknowledge that really running a learning design is actually a choice made within the teaching cycle of teachers and lecturers as they design activities, they run them with students, they get feedback on what worked and what didn't work, they get ongoing professional development, and a kind of a much larger life cycle of being a teacher and how you come to try out new pedagogical approaches. So that has significant influence on the use of learning designs. And that itself is influenced by all of these other things, your educational philosophy, your understanding of research literature and methodology, the kind of constraints or characteristics of values of your students, your staff, your institution, your external accreditation agencies, all of those things. All of them affect what happens in the teaching cycle. And the other bit we wanted to just capture in the diagram was this issue that the level of granularity that you are designing for will affect choices you make. So if I'm designing a half-hour lesson, I will design in certain ways. If I'm designing an entire unit for a semester, say 13 weeks of, 13 or 26 lectures, I will design in a different sort of way possibly at that level. If I'm designing an entire degree program, I might design differently. So that's an issue that you would also want to have in mind when you try and look at a learning design. The reason I want to capture that bit today is because when we come to TBL and equally problem-based learning, in medical context, it's a fascinating case of a pedagogy which operates at both the very low level, but then also at a kind of macro level many times. So your typical problem-based learning or TBL example down here at learning activities might describe a set of activities over a couple of hours. Whether they're done in one day or over several days, that's up for grabs. But it's a couple of hours worth of activities with a particular structure. But it sits within a larger degree program where it's possibly used many times over many years. And so you might have 80 problem-based learning examples that you run over 4 years that make up the heart of a medical degree. Or similarly, a large number of team-based learning activities. So I like it because it's an example where, in a sense, a small set of activities then gets replicated up and used widely, but then it forces you to ask questions like, okay, well, we've kind of got our pedagogical approach worked out, but the content now is crucial to make sure that we have the right mixture of content across all these different problems. Okay, so let me tell you a little bit more about team-based learning and how it fits. Essentially, as I said, it's a process that tries to take some of the LD framework issues in terms of a structure of events, but also the practice issues of a certain way of learning and to make that an effective way of learning. And TBL, which I'll show you an example of in a moment, it's got quite a few, but it's a flipped classroom type approach. That's one of the core things that's part of it. It has both individual testing and group testing as part of it. But it's also got kind of group debate and co-construction because the groups argue about what's the right answer to the questions and they try and persuade each other of the answers before they get submitted. And because you've got groups of sort of 5 or 7 doing this in a class of 60 to 100, there's this really interesting competitive element in that each team's trying to do the best it can compared to the other teams, and that data will all be collected and often shown as part of the overall process. The other thing is that at the end of a set of activities, there will normally be what they call application exercises, so a practical case study, where the students will go through these kind of steps again. And those are typically quite challenging real-world medical cases that will require them to apply the more sort of fundamental scientific knowledge they've learned in the earlier tests. One of the things that I think is important to team-based learning is that it relies on long-lived groups, so groups you would be in for, say, a whole semester or a whole year, and you keep coming back to them again and again. So you pick up kind of patterns of interacting with each other and getting to know each other's strengths. So that's a part of how it's used at LKC, and it's worth saying that one of the challenges of running sort of a one-off problem-based learning session, if you just kind of try one with your students, is that it takes a little bit for the teams to get going, and so that can make it a little bit challenging first time up. But equally, this kind of competitive element's really interesting to watch, especially with medical students who often have a pretty strong competitive sense in their own right. If you're interested to read more on team-based learning, it's been around for quite a while, but that Michelson and Knight book from 2004 is a good summary of it. The fascinating thing about the field is that it's been almost done entirely without technology, at least without computer technology. So people hold up cards to say their answer, like answer B or answer C. And when they work in groups, they have these things they call scratchies, which are kind of like, it's like the lottery scratchies where you have a list of A, B, C, D answers over 10 questions, and in your team you decide which one's the answer and you scratch it off to see if there's a tick hidden underneath or a cross. And this has been going on for sort of 2 decades as a core part of typical TBL. And so when we came into this, we were one of the very first people to actually say, well, technology maybe can help us with that, or at least computers can. So let me give you a quick overview of a typical sequence of activities in TBL, and then I'll show you a short video of a live classroom with that happening at LKC. First off, there's preparatory materials. So this is study that's done before coming to class. So classic flipped classroom kind of approach. These might be videos, case studies, readings, whatever it might be. That's done before they come to class. When they arrive in class, each student's given a set of multiple choice questions, typically about 10 to 20, and they do them on their own in kind of semi-exam conditions, no talking, but they don't find out the answers. So they just do all of them. But all the answers are recorded. The teachers can see them later on, but for this stage, the students just do it on their own. That's called the IRA, or the Individual Readiness Assurance, or the Individual Readiness Assessment. After that, then they move to the TIRA, or the Team Readiness Assurance. the teams then work together, about 5 to 7 students. They have the same set of questions they've just done, and now they argue with each other as to which answer is right or wrong. So they've all just done them individually. Now they talk about, well, I had B, you had C, and they have to persuade each other of which is the more likely to be the best answer. And the thing that makes this work is that if they get the answer right on the first go, they get 4 points for it. If they get it wrong, they get to have another go. They'll only get 2 points if they get it right the second time. And if they miss it, they'll get 1 point the third time, and then nothing from then on. So there's quite some incentive to make sure that your first answer is the right answer. So that's what happens in the TIRA section. While they're doing that, often questions will come up along the way of like, I really don't understand why that's the right answer, or I think actually there's something wrong with this question. What about this possibility? And so they have this idea of burning questions. And burning questions are where the students can type in or write up on the board or something questions about a particular question that they want more information on, where they see something more is going on. So after the TIRA stage is done, the burning questions will be collated, and then depending on how it's being run, the content expert might at that point pick up a few of the burning questions and speak to them, or the burning questions of one group might be answered by another group. So another group will see the burning question and go, oh yeah, we had the same debate, but here's the answer for why that's not right or something. So you'll see teams teaching each other across the classroom.
Do teams get points for providing a burning question answer to another team?
No, at least not that I've seen. There may be other variants where they do it, but there's certainly a bit of prestige in doing it. And the content expert at that point will then sort of say things like, yes, well done, that's fantastic, or it'd be like, that's pretty good, but there's a bit more I need to tell you. So
they get feedback that's very specific to their response.
Yeah.
Thank you.
So that's a little bit of the burning questions. That'll go for a period, 5-10 minutes, depends. After that, then they'll have application exercises. So this, they'll be given a real case study of, a patient or something with quite a lot of detail based on the topic they've been addressing. And then they'll have another set of multiple choice questions where they need to try and answer it. And there's different ways of doing this, but sometimes the students each group will have to decide its answer, and then they'll all have to hold up cards with their answer on so they can all look around and see who's got it. Or sometimes they'll do it on the computer again, and then the computer will show all the groups different answers. So they'll do that over a number of questions based on the case study. There may be more than one case study depending on how it is. And at the end there'll be discussion and conclusion of what's been learned. So this whole thing is typically several hours, maybe 2 or 3 hours all up. They often do a break in the middle of it, so they'll break at the end of burning questions, maybe go and have lunch, come back and then do application. They don't have to, but that's not unusual. So let me now show you just a little video that gives a walkthrough of this.
Hi, you're about to watch a team-based learning video. My name is Dr. Preman Rajalingam, and I am the lead for team-based learning facilitation here at LKC Medicine. In each session, there is a team-based learning facilitator and content experts who are the faculty who run the sessions. Team-based learning is a sequence of in-class activities designed to engage students in meaningful learning. Team-based learning begins with students preparing for class by going through TBL preparation materials. Learning outcomes are provided for each topic to indicate what students are expected to learn from the material. The first activity in class is an individual readiness assurance process. This is an MCQ test where students are tested on their understanding of concepts which are reviewed before class. Students review concepts before class on video annotated PowerPoints, textbook materials, or recorded lectures. In this scene, you see students engaged answering these MCQ questions. It is very much like a test and is conducted under test conditions. Students will not know if they've got the right or wrong answer, but in a minute, they will do the same test in their teams as part of the readiness assurance process. And at this point, they'll be given immediate feedback on whether they've got the right or wrong answer. You will see the class go from pin drop silence to an active discussion. Student teams have a discussion, commit to an answer, and electronically receive immediate feedback on whether they've got the answer right or wrong. This drives the discussion and makes sure that students justify their answers to each other before committing. Often in the team, someone is able to explain what the right answer is to his teammates. Answers which students still are unable to get right may be raised at the class level and discussed with the entire class. We call this the burning questions.
Argument for D, whereas for E it's like completely no argument for.
If it's a very, very high risk and they actually endanger themselves, then they may put issue.
As you can see, students are actively engaged throughout the whole process instead of passively sitting and receiving information. In the discussion, students challenge each other's answers and peer teach.
This term CRLI was actually coined by
The content expert is then able to correct any misconceptions which arose and clarify any tricky issues. The purpose of the IRA, TIRA and burning question discussion is to make sure that students understand key concepts, key basic concepts which they can then apply in a realistic setting. This process also prepares them for the application exercise which happens later on in the day. During the application exercise, students are presented with case studies or vignettes that reflect the significant real-world problems faced by professionals in the field. They are often presented with real test results, scans and even simulated patients that make the cases more authentic. Early exposure in the first and second year to these kinds of problems allows students the opportunity to start to think and act like future doctors.
You may not have the time to read the content, learn how to understand the cardiopulmonary resuscitation and put anesthetic in you whatnot.
Doing this in the classroom setting allows them to make mistakes and learn from them.
This was a predisposed psychology.
I think since when we started to work alternative medical treatment, we somehow thought like traditional Chinese medicine or something like that. It was funky, not really evidence-based medicine treatment.
Just like in the hospital, students work in teams to apply their knowledge and propose specific solutions to the problems. The clock counts down as they discuss, look up resources and try to find the best possible solution to each of the questions posed to them. Each team makes a specific choice, then simultaneously reports their answers. They discuss their answers with each other, especially answers which may be different, and try to convince each other that each have chosen the best solution. Often, students come up with brilliant justifications. The content expert can then finally come in and clarify any issues as well as highlight gaps in students' knowledge.
I like this very real challenges. And this is based on the real life.
This active engage process allows students to engage in a deep, meaningful discussion with content experts and each other. I hope you've enjoyed watching this video. If you have any questions about team-based learning, please contact us.
Okay, so that hopefully gives you just a little bit of a feel what it looks like, sort of the flow of activities within it. The links there if you're interested to go and see it. So a little bit of the LAMS background to this was that NTU, Nanyang Technological University, have been using LAMS quite a bit already in a range of its programs. And so when it looked to start this up, they were looking at TBL as a pedagogy and they were saying, well, you know, could we get LAMS to try and help run it for us instead of these scratchy cards and other things that have been more typical. So we worked with them, particularly with Paul Gagnon, who led the work at LKC, to try and work out what would we need to do with LAMS to make it do this, and you know what could it do and what couldn't it do. So let me jump into a demo now of the LAMS software. And this account that I'm using today, I've given Ling the password details for this. So if any of you want to go in and play with this later on, you're very welcome to do so. This demo server also, any of you can just go and sign up for an account and just play around with LAMS. So I'm going to go into the authoring area and open up the sequence that they were using. So what you're looking at now is the sequence of activities used to run TBL within a typical class session. Essentially, there's learning resources, which is links to videos and articles and whatever thing. If you come and play this later on, the actual links to this won't work because they're internal to LKC's intranet, but you'll see a list of them. It then goes into the team setup, which is this is a special tool in LAMS which allows you as the author, the person creating this, to specify, I want a certain number of teams and how many people will be in those teams. And so you can see here these properties In this case, there were 13 teams and they are chosen in monitor, which means the actual students who will go in the teams is decided by the lecturer when it's being run, that is when it's being monitored with the students. Other options are things like random allocation, where you just let the software do it. But because it's important to have the same teams working together, it's done by hand. There's what we call a stop point in LAMS. This is where you can control the flow of students through a sequence, and that way people don't get ahead of where they're meant to be. And we call this type of stop point a permission. That is that the teacher who's running it has to give permission for the whole class to go through. There's other kinds of stop points where you've got to got a certain quiz score before you can go on, and other things. Again, I won't talk about those today. Then there's the IRA tool. This is essentially a quiz tool, but set up that they do all the questions, but they don't get any answers to that. Let me just jump into that one as an example. So by double-clicking on the tool, I can go and see the details for setting up this tool. You'll see here, there's a bunch of, quiz questions and so on. I won't look at all the detail. But I want to show under this set of advanced settings up the top here is a whole bunch of options for the way that the quiz is going to run. And so one of them is display correct answers and score after the last question. That is normally checked on by default, just as a default setting. That's been turned off here because it's essential to the way that this particular pedagogy works. Then we've got a tool called leader selection. So this is in the groups of 5 to 7, one student will need to act as the leader or the facilitator in that they will be the one to tick the box to say, yes, my group chose this answer. So you need to have a way of choosing who will be that person, and then they act on behalf of the group. So that's a tool that allows that to work. But importantly, when you come to the TIRA, which is this tool where they can have multiple attempts at it, only one student is actually able to put in the answer. That's the leader. The rest of the students can see what answer has been chosen, but they can't do it themselves. And so in a sense, there's an interesting split in roles inside the tool. One person using the tool can actually give answers. The rest can only view what's happening. And then the application exercises are essentially a set of content and then some quiz questions that they work on, depending on what it is. And those answers can be shared with others. Let me just do a quick save of that and do a preview so you can see what the student view of this looks like. So LAMS authoring has a preview option, which allows you, when you as a teacher are creating things in LAMS, you can jump out and quickly see what's it going to look like to my students, so you can see whether it's working or not. So here, this is the preview mode. That's the first set of activities. These are the links to all the videos and things that I mentioned. And then over here is the actual sequence of activities they're working through. So someone asked me earlier on, what does the student see in terms of the layout? This is what they see. It's kind of got the sequence running down the page. And as they work through it, they can see which ones are completed and which ones are yet to come. We go to the next activity. Oh, like that. And this is the team setup stage, where normally the lecturer would be then setting up the teams, but the students don't really see anything until they've been put in their teams. Because I'm in preview mode, I can skip over that and now see here I'm logged in as Lingwu. You'd see all the different people in their teams and on we go. I won't go through every step in this, but I just want to give you a little bit of a feel of the flow of it. This is a gate, and so normally the students can't go through the gate until it's been opened by the teacher. Because I'm in preview mode again, I can just skip over that. And now we get to the IRA, the Individual Readiness Assessment. And so this is pretty standard multiple choice questions. In itself, that's not that different from what we're used to from other tools. But I'll skip that and get to the TIRA, which is a little bit different. See, got to actually do the work.
a summary of all my answers there. Now it checks whether I'm going to be the leader or not for my group. Yep, okay, I'll be a leader. And there's ways that they can change the leader if it's not. Right, it's meant to be. Another gate. Again, I can skip that. I just want to get up to this one, which is the tier. So this one where the group has to agree on the answer and put it in. And if they get it right the first time, they get 4 points. If they get it wrong, then they get 2 points and so on. And the funny thing is, remember I mentioned the scratchy cards that have been part of this area? We're actually told to mimic the scratchy experience. So when I click on one of these answers, it actually scratch like that. So, okay, so I got that one wrong. So now I have to have another go. There we go. Okay, so I got it right. So that means I would get 1 point because I got it out of the third answer. I won't keep going. I just want to just give you a little bit of a taste of the way that works. Okay. So, as I say, you're welcome to go and have a bit of a play with this later on if you'd like to explore it a bit more. But that gives you just a little bit of a feel for the LAMS authoring environment with the sequence of activities and a bit of an oversight of what it looks like to the students. In a few moments I'll come back and I'll show you a live class version with more data in it to see how it works. Okay. So, I want to say just a couple of things from a technical point of view of LAMS. You know, we had this big piece of software, it already did lots of sequences of activities and these kind of things. Which bits were easy for us to do in terms of this TBL pedagogy? What was new or different? Well, the sequencing activities, stop points, all of that was, vanilla for LAMS. The fact that the IRA said, don't show the answers to the students, that's an important part of the pedagogy. We already had that as a feature from years ago, so that wasn't any trouble. The burning questions bit, where the students get to type in their questions and have them collated, we didn't have that exactly, but we had another tool in LAMS called the LAMS Q&A. The LAMS Q&A was everyone gets to type in some text, and the text then gets collated and represented back to the whole class. That's basically what a burning question is. So we just took some of that functionality and connected it onto the quiz functionality. So that wasn't too hard in technical terms. But the TIRA, the one where they're in the groups with the leader rubbing it off, that was challenging, and challenging at 2 different levels. Firstly, we didn't have a multiple response option within our quiz tool, so the idea you could, try once, get it wrong, and then try again and get less points and try again like that. It's not that common, but it exists out there. You'll find multiple response quiz tools, out there. So we had to build that as sort of like some extra features within the tool. Okay, that itself wasn't especially challenging, but it needed to be done. But this bit about having leaders who respond on behalf of their group, that was new, and we didn't have anything really quite like that in LAMS. And so that took a bit of work to think through how we would do it, and ended up meaning some fairly significant new core infrastructure for LAMS to be able to do this. In a sense, you might think of it as roles within groups. So we've got groups of students, but even inside the groups, there are different roles within them. So what we end up calling a thing called Select Leader or Leader Select tool. And this is where if you have a group, you can nominate a leader of that group. And this would be a general bit of infrastructure for LAMS you could use anywhere, not just for this tool, but a new concept.
We took the TIRA, the quiz tool, and we made it what we called leader aware. That is, it was a tool that knew that if you applied a group with a leader in it onto this tool, it would change the way it runs so that only the leader could put in an answer and everyone else could see the answers but couldn't change them. So we tried to make sure that the tool could work in different ways depending whether this leader concept had been applied to it. So once we'd done all that, then we could do this core bit of the TBL pedagogy. So it did take a bit of additional development and thinking. But what was nice was that this concept of a leader-aware tool based on a group that's got a leader, we could start applying that to other tools in LAMS. So we took the LAMS Q&A tool, which is just, everyone gets, and we made that one where you could have a group discussion, the group agrees on one answer, the leader types in the answer, that then goes up to the screen with all the other groups' answers. So if you had, 36 students in groups of 6, you'd end up with 6 answers being the collated answer of each group. So that was a nice bit of new functionality for LAMS to get as a kind of byproduct of the new development from TBL. Okay, so I just want to summarise this bit and then I'll show you a little bit more of the monitoring. So that functionality turned out to be, in my view, really good kind of stretching of LAMs in a good pedagogical way. This idea of tools that could be aware of a leader and that, you know, one person could put in information on behalf of a group. And good for sort of hybrid learning context where you've got people talking face-to-face and using the computer rather than just being, say, fully online. And behind it, you know, this is a slightly technical way of thinking of it, but there's a kind of hidden ontology behind LAMs. Like if you took the XML structure of the LAMs, you know, learning design way of describing the world, you know, internal to it, there is, we've never specified it, but there is an ontology that's hidden behind that. And so what we realised was that this concept of leader-aware tools was not part of our existing ontology, but our existing ontology was built in a way you could slot it in and it wouldn't kind of break the whole structure. In fact, would add a really nice sort of new ideas to it. So that I liked. The one thing it did, which does push beyond the normal boundaries of LAMs, these long-lived teams are supposed to be able to exist over multiple TBL sequences. You know, it's the same group of people. LAMs doesn't normally have that concept because it views everything through the lens of a sequence of activities. Because the idea for LAMs was it would always be plugged into an LMS. The LMS would look after teams and classes and authentication and all that. LAMs would just be, you know, a URL that says click here for activities for week 3. You go in, you do your activities, you come back out. That's it. So by saying, well, we're going to actually have, you know, 6 or 10 TBL sequences over the next 3 months, and they will use the same teams across all of them, we have to actually create a new kind of container outside of the normal LAMs area to hold the information about who those teams were and then apply them into the LAM sequences. So that one was a little bit pushing outside the boundaries of the normal way of LAMs thinking. And from where I sit, some of the changes that TBL required were inside the tools. That is, a particular tool, an assessment tool or whatever, had new features inside it. But the leader selection and leader aware is more like core infrastructure. It's the engine of LAMs, now has new concepts about the way it can think of working with students and with tools. Okay. So that's a little bit of a summary of some of the development. I mean, obviously there's a great deal more behind that, but I just wanted to sort of paint that bigger picture. The second thing I want to show you, just as kind of the getting towards the end of things for today, was having done all of that with LKC, and it's all gone very well, everyone really liked it. The lecturers who were running this said, look, we'd like an easier to use monitoring interface. We'd like an interface that sort of summarises for us what's happening with our students in real time. So I want to show you a little bit of that now using a different example. Okay, so this one is an old session from LKC. So it's not live students, but it was an example. And so I just need to grab my... Okay, so what I'll just show you is, I'm not going to have time to do all the things, but this is an example of the main LAMS monitoring environment that you get when you're using LAMS normally, that is without the special things we did for LKC. You can see the sequence of activities and you can track student progress within them. You can actually see lots of little students down the bottom here. They've all finished the sequence now, but when it's running live in class, you actually watch students moving away through the sequence so you can see in real time where they're up to. And there are some things you can do to sort of see that, but you can't get real detail about what's going on within the groups. So all of these here were built as kind of special monitoring features for the key bits of the TBL pedagogy. So one of them is to show us the teams of all the students. So here are the different teams. But most importantly here you can see the scores for the students on the individual readiness assessment and then the team score there. If I click on comparison. It'll also give a kind of graphical representation of that. There's a summary also of the gates, so all the gates, so that you can the teacher can see in one place, right, I'm ready to push them on to the next activity, hit a button, the gate will open. Probably most interesting then is the data on the IRA and the TIRA. So this shows a summary of the questions that they're doing, but if I click here on student choices, what I can see now is the green is the correct answer for each question, so question 1, 2, 3 and so on. And I can see the spread of incorrect answers around that. So at a glance as the teacher I can see, are there any particular questions that there's some real struggling with, or are there particular options that people are getting wrong quite regularly? And interestingly, you'll notice this one down here was question 6. So 48% of students actually getting it wrong. So immediately I know, okay, something's going on there. Now, it might be a problem with the question, or it might be that it's a really tricky concept and needs more help. So that's been really popular with the lecturers to be able to see in real time how things are progressing. When I come down to the TIRA, so the group version of this, I can do the same thing again. And so it's showing now all the teams down here. Green is where they got the correct answer. So basically, all the teams got the correct answer once they'd argued with each other, except for this question 6. And more than half of them got it wrong. So immediately you would know as the teacher that there's a conceptual issue there or possibly a problem with the question wording. It's going to be perfect for burning questions. And in fact, if I go to the burning questions summary, this is very hard to see, but there's a tiny little number here next to each of those. Sorry for those at the back. That's the number of burning questions for each of the topics. And they're all 0 until we get down to question 6. And here we can see there's 2 down here, and there's 2 teams have typed in, okay, don't understand what we need a bit more. This one's only a fairly brief example, but when they do this in class where there's lots of burning questions across many ones, notice this little thumbs up button here. The students can go in and like certain burning questions, so the teacher can see which burning questions are the ones of most interest to the wider group, and then go and speak to those. So if you're a lecturer and you can only answer about 5 of them and you've got 15, you can say, all right, everyone, let me know which ones are most important to you. Bang, 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 bang. Right, let's choose those and we'll talk about them. And then the application exercise, let me just give you, what it's done here is it's summarised the answers, some of which are multiple choice and some of which are text, across all the different groups when they've been trying to answer these practical tasks. So again, as a lecturer, I can see, all right, what are they saying? Where might there be a misunderstanding? What do I need to comment on? And so the reason I want to show you this today is that what I find interesting about this is there's actually no new data in what I've shown you. Every bit of information there was in the LAMB system. But it was either hard to get to or it wasn't kind of collated in a way that's most useful to the teacher who's running it. It's kind of like, yeah, LAMB's got the data there, and if you're willing to dig around, you'll find it. But effectively, LKC have said to us, we want you to kind of consolidate the key bits of information in their kind of pedagogical structure. Show us what's happening with the IRA. Show us what's happening with the TIRA. Show us the burning questions. So the person running it in real time can just grab that on the spot and go, right, I've got a problem here, or, okay, now I need to do this. And that's something we've never done before in labs. We had a kind of vanilla monitoring environment. We've never done a kind of custom monitoring environment to suit a particular pedagogy. But that's what we've done here, and it's been very popular with the lecturers. And so when I end off, I've got a question for you that I've been asking myself lately about. In a sense, just coming back to this question of what we might call a kind of pedagogy-specific overlay, in this case, a TBL overlay on the monitoring environment. What's effectively done is it's actually hidden a lot of the flexibility that LAMS has under the surface. LAMS can do all sorts of things, predict, observe, explain, and problem-based learning, and all these things. And it's kind of actually pushed that to the sides and said, no, you're just doing TBL. So let me show you just TBL information about your students. And that's what's been popular. Okay, so last thing before I wrap up is, in terms of some work in Australia, so the Medical School at University of Western Sydney have recently run a thing they call the clinical classrooms, which was inspired by the work at LKC on problem-based learning, and they did this on an infectious diseases unit. It was only a handful of classes, so it wasn't, you know, a big long thing. And it was TBL in style, but it wasn't an exact match. So the ERA, the individual task, students actually did it before they came to class, rather than sitting in class doing it. For the TIRA, because of limited time, they didn't do all the group arguing. They just did a whole class, you know, talk about what the correct answer was compared to what they'd thought. So they lost a little bit of that co-construction of meaning and argument part of it. But they did then have the application exercises done in groups and with people saying what answers they got. And that was very popular with students. They really liked that. They liked the sort of hybrid of using their laptops and arguing face-to-face and so on. Part of what the reason this was done was to address poor student attendance, which is one of the big issues. On the downside, it was mandatory that they come to these sessions, so that's not a good way in one sense to, did this solve the problem of poor attendance? On the other hand, it was very popular with the students. They really did like doing this in class. It brought things alive in a way that a traditional lecture often doesn't. And they really liked the application exercises, partly because it was real case studies, but also sharing with the class, arguing across the room, why they answered that. That went down very well. But I think the other thing I should say is that those who did this, and my wife is one of them because she works in the medical school there, she wasn't the leader of the projects, but she was involved. She said it was a lot of work. It's a lot of work to do this, a lot of work preparing the video lectures and materials, as often happens with flipped classroom, a lot of work to get it up and running. But her sense was it would be a lot less work as it became a more regular pattern. It's always hard to do it once off. All right, so let me then wrap up. Personally, I think what LKC have done with TBL has been very successful in both pedagogical and technical terms. It's been very popular with the students. They really like it. It's really set them apart as a new medical school and a new way of doing things. It's a pretty compelling answer to the question of why should I bother to come to class? As you saw in that video, why wouldn't you? That whole experience is at the heart of what's going on. And interestingly, it fosters learning not just inside teams, as PBL does, but across teams. And it's asking people to debate with each other what they came up with in their teams. That's a really nice element to it. And you saw that sort of bigger group where they're talking the microphones to each other. That adds something that you don't get with PBL usually. From a slightly more technical point of view, I like the way that TBL stretched LAMS, if I can use it that way. It pushed us to new concepts, which once they were in LAMS were of wider benefit than just TBL. This whole leader-aware approach to tools I really like, and it's very well suited to hybrid learning scenarios. And I'll wrap up with this. The question this has been on my mind is, having seen how popular the monitoring changes were, and how they really helped the lecturers to kind of focus in and get the TBL done, that's great. It took some money to develop and all the rest, but that went well. But it's made me think, my hope for LAMS for many years is there could be a flexible toolkit that people could do lots of different pedagogies with and go to their heart's content. And lots of people have, and that's been great. But watching this, part of me wonders, have we done it the wrong way? Should LAMS have been sort of the engine under the hood, and then people choose a pedagogy they want to use, and then you build a layer on top of LAMS, which kind of hides all the other pedagogies you could have done and just shows you the details of the pedagogy you want to use, say TBL. And if that's the case, then for me at least, I need to think of LAMS in a different way. LAMS is not the whole car, it's just the engine, and you need a different shell around it to suit your purposes. If that's the case, though, that's a problem because it's going to be expensive to build all these different shells, and in a sense it's limiting because once you build a TBL shell, it just does TBL. So I'm not sure to what extent that's a forward step. But on the other hand, it clearly has made a big difference to the real-world implementation. So in that sense, I'm very much in favour of it, at least to the extent that this group of people were willing to do that with LAMS. So that's kind of a bit of an open question for me at the moment as I look to the future of, do I keep building more general flexibility into LAMS, or do I start carving new slices of functionality over the top of it to suit different pedagogies? I don't have an answer to that. I thought you might want to have a go at it, but that's what's on my mind. So if you're happy, I'll stop there and take questions, comments, suggestions.